The rise of electric vehicles has sparked a revolution in the automotive industry. In just a few decades, or perhaps even sooner, the way cars are powered, built, and driven will be transformed forever. While many see this shift as a crucial step toward combating climate change and promoting sustainable living, it presents a unique challenge for legendary brands like Porsche. These brands face immense pressure to deliver the high-performance vehicles their customers love, while simultaneously embracing eco-friendly innovations. But here's the catch. The level of performance Porsche enthusiasts expect has traditionally relied on internal combustion engines, which aren't exactly environmentally friendly. Porsche, however, has come up with an intriguing solution. Some industry experts are now suggesting that the company's groundbreaking six-stroke engine could revolutionize the automotive landscape, perhaps even rivaling the rise of electric vehicles. So, what's the story behind this innovation? Let's dive in. Oliver Blume, Porsche's CEO since 2015, has been a driving force behind these bold moves. With a career spanning Audi, Seat, and Volkswagen, Blume has steered Porsche towards sustainability and innovation while showcasing exceptional crisis management skills during pivotal moments like the global pandemic. Under his leadership, Porsche has successfully navigated the challenging transition to electromobility, proving the brand's resilience and forward-thinking approach. However, he has also been confronted with a particularly seismic challenge. Navigating the automotive industry's shift toward electric vehicles is not easy. But he has risen up to the challenge, and under his leadership, Porsche launched the Taycan, the brand's first fully electric car, in late 2019. This move marked a bold step in Porsche's commitment to sustainability and environmental responsibility. By 2030, Blume aims for more than 80% of all Porsche vehicles sold to be fully electric or plug-in hybrids. But he has not given up on internal combustion engines either. Blume is playing this game both ways and wants to see what picks up first. One thing is for sure though, their new six-stroke engine is revolutionary. Before we move on to that, let's get some context first. Sales figures under Blume's leadership have reflected his strategic direction. In 2022, Porsche delivered 309,884 vehicles worldwide. This was an increase of 3% compared to the previous year. The Taycan itself saw impressive sales growth, cementing its position as a core part of Porsche's portfolio. Despite global supply chain disruptions and the pandemic, Porsche's performance demonstrated resilience. Blume's focus on sustainability extends beyond vehicles to operational processes, emphasizing localizing supply chains, reducing logistical complexity, and integrating environmental and social criteria into supplier evaluations. Under his leadership, Porsche also underwent a historic IPO in September 2022, raising over €9 billion. This move was intended to give the brand greater financial autonomy while supporting its ambitious development plans. Speaking of development plans, Porsche has unveiled something big. Before delving into Porsche's bold engineering innovation, let's take a step back to appreciate the principles of a traditional combustion engine, a technology that has powered most vehicles for over a century. The classic four-stroke engine follows a systematic cycle: intake, compression, power, and exhaust. In the intake phase, a mixture of air and fuel is drawn into the cylinder. This is followed by the compression stroke, which packs the mixture tightly to prepare it for ignition. The power stroke then ignites the mixture with a spark, forcing the piston downward and generating energy to propel the car. Finally, the exhaust stroke expels the burnt gases. This intricate yet efficient sequence has been the backbone of petrol-powered vehicles, delivering the visceral thrill and raw performance cherished by driving enthusiasts. But this approach is going extinct in the face of the electrification of vehicles. Porsche's response? Make a more efficient and sustainable version of the traditional internal combustion engine that will help minimize emissions and maintain the level of performance we all love and cherish. This brings us to the revolutionary six-stroke engine design. This concept adds two new stages to this classic cycle. Building upon the standard four strokes, Porsche's innovative engine incorporates a second compression and an additional power stroke. These extra steps amplify efficiency and performance. The core of this system lies in its specially designed crankshaft. It features a dual concentric circle arrangement that enables varying stroke lengths, allowing pistons to achieve two distinct bottom dead center positions. This configuration facilitates the additional compression and power phases, creating more combustion cycles within the same engine operation. The result is a remarkable combination of benefits. First, the design significantly enhances fuel efficiency by making better use of the air-fuel mixture. Second, it optimizes the combustion process, reducing unburnt residues and improving emissions. Most importantly, the additional power strokes generate increased output. In a world rapidly pivoting toward electric vehicles, Porsche's unwavering dedication to preserving the combustion engine, specifically for the iconic 911, might seem counterintuitive at first. Yet, when you consider the legacy and cultural impact of the 911, Porsche's efforts to keep it petrol-powered make perfect sense. The 911 isn't just another car in Porsche's lineup. It's the soul of the brand. This rear-engine marvel, tracing its roots back to 1964, has defined the Porsche ethos for decades. Despite external pressures to abandon it, such as in the late 1970s when then CEO Peter Schutz famously saved the model from discontinuation, the 911 has remained a cornerstone of Porsche's identity. Today, it stands as a symbol of timeless engineering and an emotional connection to the driving experience. Porsche engineers have declared that the 911's combustion engine is forever, underlining its unique status. Unlike other models, it's not seen as a candidate for full electrification, as doing so would compromise the very essence of what makes the 911 special. However, the flat-six engine that powers today's 911 can only be refined so far. When it reaches its technological limits, what then? For most manufacturers, the answer would be to replace it with an electric drivetrain. But for Porsche, that's not an option. The 911 deserves more than just conformity. It deserves innovation that honors its legacy. That's where Porsche's investment in e-fuels and the potential development of a six-stroke engine come in. Whether the six-stroke engine becomes a reality for the 911 remains uncertain. It may debut in the next generation post-992, or Porsche might choose to extend the life of the flat-six for as long as possible. What's clear, though, is that Porsche's resolve to preserve the petrol-powered 911 is about more than just tradition, it's a statement. It reflects a profound understanding of what enthusiasts value, the visceral thrill of a roaring engine. The Porsche-efficient internal combustion engine reimagines the classic sequence of intake, compression, power, exhaust, adding a second set of compression and power phases, effectively creating intake, compression, power, exhaust. This aims to increase energy extraction from each fuel cycle, improving overall efficiency and reducing emissions. At its core, the engine features an inline six-cylinder design with direct fuel injection for precision control of the air-fuel mixture, ensuring optimal combustion under various operating conditions. Advanced turbocharging further boosts performance by supplying the engine with compressed air for enhanced power output without significantly increasing engine size or weight. The incorporation of hybrid technology allows the engine to synergize with electric motors, offering the advantages of reduced emissions during low-speed operation and improved efficiency at high speeds.